Hi guys, this is Mackie from the Babylon Toolkit, and I'm here today to quickly make a getting started video. Basically how to set up your project and get you going with script components, because basically script components are the heart and soul of the toolkit. All components, even all the pre-built components that I make and all the components that you will make will be based upon script components, editor script components. So I'm here on the Babylon Toolkit Developer Portal, and I'm just going to click in here to the online documentation because it's really easier to get to the location that we want to download the Babylon Toolkit. In the Getting Started page here, we have the Download Babylon Editor link or Babylon Editor Toolkit link. So we'll just click on that. By the time you take this or see this video, we'll be on the Alpha 12 version. You need at least the 3.3 Alpha 12 version. The PR just hasn't gone through yet, but it will shortly. So when it does come through, you just click in and download the Unity package. I've already clicked and downloaded it. I have the Alpha 12 version on my desktop here. One quick little note I want to make about adding the packages on each platform, Windows and Mac, um, and I'm not exactly sure where it is on the Windows, but on the Mac, it's under your Library Unity Asset Store folder. You can probably Google where to look it up on Windows, but right now, the toolkit is not available on the official Unity Asset Store yet. The the post is still pending, so by the time we get out of beta, I'm hoping to have it available directly on the Asset Store. When it is available on the Asset Store, it stores it on your local machine here. So if you just drag a copy of it to a folder in your Asset Store, it'll be available when you start up your Unity project. And I'll show you how to do that here. Now here we'll create our new project. So we'll just hit our new button here. And we're going to call this Getting Started. Now we don't need analytics, but on here, if you have whatever was available in that store is available here as asset packages. So if we put it there, we can just kind of click that there. And when we create our new package, Babylon Toolkit will already be in our new project. I am going to leave that off just so I can show you how to manually put that package in here. So we're going to start out with no packages at all and just create a complete empty project. And we'll give Unity time to compile up an empty project. And we at least get like a default scene and things like that. And the default scene will basically consist of a scene file called sample scene, I believe. And that file has or that scene has a camera and a light, a directional light already set up for us. So we have a main camera and a directional light already set up in Unity. And if we were to look, this is kind of what our game view would look like. And this is our 3D view that we have for development. Now, throughout the documentation, there'll be lots and lots of references to, hey, go look at Unity here, go look up this documentation here. And the reason that is because I tried to build the toolkit to use the native Unity functionality, how you add a component, how you add a script, how you do materials, how you bake light maps. They're all the same. The only thing that's really different is Babylon might have some specific Babylon components that I built that take advantage of Babylon specific functionality. But as far as adding scene hierarchy and game objects and attaching scripts to them and components and materials and shaders and all of that stuff, it's standard straight up Unity. So with that being said, let's get started here, and we're going to need to add our Babylon toolkit. So we're going to go import package. Under assets, import package, and we'll say custom package. I had mine on my desktop, so I'll select that, and there's our Babylon editor toolkit, and we'll just select that. And part of one of the advantages of using the Unity editor is their whole kind of asset management, packaging, making Unity packages, being able to share content and things of that nature so that you can kind of use and package up either entire games, pieces of games like this toolkit here, or even components and specialized components like maybe materials or maybe some pre-made libraries of things like particle systems and things of that nature. But the same way that you would normally do that kind of thing in Unity using C# code, but you just will be using your Babylon system. So we're going to add this whole Babylon folder into our project. We can either say all, but it's pretty much all selected. And that was the only thing we had there. Now, it's kind of open to how you, the hierarchy of how you want to organize your scenes. If you want to have a folder called like games or resources or however that you want to organize them. I'm a bit particular about mine. I like to have only a few items in my root, and then I kind of um, subcategorize everything up under that. So we're just gonna switch this around as soon as this finishes compiling, just so you can see kind of the way I organize them. But you're free to organize your folder structure however you like. It's almost finished here, adding all the assets for the first time. Okay, now the first thing is I don't like to have a lot these folders in here like this. I like to have just kind of main categories up here in my root folder. So I'm going to create a new scene just so I can get out of my sample scene, because I'm going to move that guy. So now we're untitled and we have a scene here. And in our root, I like to create a folder called, I'll call this first one resource. And this is going to be where we dump in all things like general images and things that we get off of maybe the asset store, just general resource. You can't call it resources plural because that's just reserved one, but that's like resources where I like to keep all my main folders, so I don't kind of clutter in all of the different things that I might acquire for this project that'll go under the resource folder. I like to keep up at top if I'm making a game, and I kind of keep them in brackets like this, maybe my game folder like that. So that's kind of always at the top. And I'll put all my scenes and scripts and everything's like that up under the game folder. So I'm just going to move this, as a matter of fact, to my game folder. So now I have my game folder, my that, and then sometimes there are where I don't want to pollute my game folder, but I want to be able to just temporarily add stuff up in here. So I'll create a temporary folder. So we'll just call this temporary. Now you don't have to organize it this way. You can do it however you want, but I like to keep my root clean. So now I have everything that's going to be in my game project here. My Babylon folder is pretty much, you won't touch this. These are kind of where your toolkit is. Only time you'd be going in here is if you're going to be changing out some of your templates or anything like that. And then resources, where I'll dump all kind of stuff that I get from the asset store or somewhere else. And then I normally keep a temporary folder for that. So now in here, in our scene folder, we'll pop back to that sample scene now that it's in the right place. And now we have our sample scene loaded up here. Over here, I also like to create a couple of folders just to organize stuff out a little bit better. I'll create a scripts folder. I'll create a materials folder. And that'll probably work for now. Sometimes I create a texture folder, but probably not going to use any specific textures for this one. But normally I would create like a textures folders. That way for all my assets in like a models folder and things like that as you start to go along. But we're just going to use simple geometry now. With our toolkit loaded, we have a Babylon options up here. So we'll go and select the scene exporter. This is our main interface for selecting all of our project settings for how we'll build the project. And I like to drag mine over here next to my navigation. That way it's kind of, I always have the scene exporter, which has to be up when you're running the game. I always have its options available to me over here at the side. First thing you want to go do is set up your options now that you have this Babylon Toolkit Scene Exporter running. So now it's kind of running as a Babylon game development editor. One of the things that you want to do is I like to use Visual Studio Code. And for Visual Studio Code, you have to initialize the workspace in the file folder settings. So you're going to want to click that once to set that off. Now we want to set up our project. Make sure that we have everything set up to run our game. Initially, we leave this unchecked because again, we're going to make this come through the asset store, and you can't really take over Unity. Their default implementation is to make Unity games, but for us, we're going to take over this whole entire editor and make this our Babylon game. So I'm going to click that button there to say attach the Unity editor. So now when I click this play, it really does this full building preview down here. And I like to show my render stats. You can put them on milliseconds or frame per seconds. I like to start them off on frames per second. Basically, a lot of these are just your publishing options that, if you want to include metadata, the module, how you want your splash screen to look, the different color schemas, things of that nature that you can play around with. But primarily, you want to attach to the editor, and if you want render stats, you want to enable those. Your next one is probably the TypeScript. I'm a TypeScript guy, so I'm going to be using TypeScript in this project. ES5, I'm on a Mac, so these are my folder locations. And wherever computer you're on, it will try to detect your locations, but you may or may not have to go get and put your locations up in here. The rest of these are pretty much standard. I am going to, if you want to enable Xbox services and Windows platform on your game, you would check that. And these are pretty standard options that you can go through and check out. These are the default options for how all projects and scenes get exported. And your folder options that you have up here. Where the folder gets, by default, we create an export folder in your main Unity project. So in this main project, we'll see revealing folder here. This is your main Unity project, and we create this export folder outside of our assets folder. It's important that you do it outside because inside it's expecting Unity assets. Outside is going to be our stuff like JavaScript assets that are designed for the web. You can also change your export folder if you wanted to point it somewhere else, or maybe point it to an existing www project somewhere. You can change your existing folder. Now that we have everything set like we want, we're just going to save our export settings so that everything is saved for us. And we're just going to hit build. Now we'll build our project out here without putting anything else up in there, just kind of saving our compiling options. So now it's compiling any script. There's none in there, and it is complete. Now that runs our game, and we get exactly what you would get in the game, which is pretty much nothing. But as you can see, the skylines and the skyboxes and everything match out to a T. Now we're going to bring some geometry into this little sample scene. So let's come over to our inspector view so that we have, we can see our properties. And first thing we're probably going to want to do is, if you're making a full scene, a scene that is not being used for just like as a dependency or just import meshes only, you're going to want a scene controller. And a scene controller is basically a built-in game component that you're going to attach to one kind of master game object type deal. I like to call mine scene controller. So we'll call this scene controller, and they can't have spaces in there. And my scene controller, I like to be first, and then I like my light next, and then my camera. And on our scene controller component, sitting at 0, it's empty, so you won't see anything in the world because we won't have anything on there. This is just kind of going to be a catch-all that has all of our components that aren't specifically related to an item, but more of the scene as a whole. So we'll come over here and we're going to add a default scene controller. The main advantages of a default scene controller is that if you don't use a default scene controller, all of the items that you might want to enable on like fogging and lighting and things of that nature, you'll have to do those in code. So you'll have to create a script component and go ahead and every time you want to create a game, go ahead and manage all that stuff. But if you create a scene controller, it has plenty of options in here that you can use to kind of preset up things on your scene. So you're going to want to use that guy to on your primary scenes, things that are not just mesh only import scenes. Now, once you have a scene controller, like we do here, we're going to want to create a plane. So we'll go 3D object. I'm right mouse clicking right here, and then I'm saying 3D object, or you can come up to components and um, choose different game objects and components. My bad, it's game object and 3D object and cube. Components is when you add an existing component to a mesh, and we'll get to that one just quickly, but we will add a cube. So puts cube in our scene. Our translation's at 0. That's just fine. We will also add a plane. So I'm going to create a plane and a cube. Our plane and our cube, we're going to raise our cube up to about 2. And we're going to make our plane scale it up to about 5 so we can, oops, wrong guy. That's scaling our cube. We want to scale our plane to 5 by 5. Now, if we swap over to our game view, that's kind of what our game would look like. We got a kind of a crown, our skybox, and kind of a cube floating in the air. Let's just build that and see what we get. Compile project. Compile time is pretty fast. The time that takes really the most that I've noticed is the actual invocation of the external process of the node to TypeScript compilation. That puts about 6 to 8 seconds on basically all compiling. Other than that, everything else is the import time. So about 6 to 8 seconds of that time was just kind of starting up the compiler and getting things going there. But let's hit preview now. Now we pretty much got our same view here. Down to our shadows, we got our skyline with our white textures and things going there. Now, if we were to look in our console, it's telling us here that we got a couple of warnings. First one is that it made our default project layers, so that if we were looking at layers, there's kind of 3 different layers that are Babylon specific. We'll get into those, and I think they're in the documentation as far as Babylon prefabs. And we'll be making specific videos for that. But the main one we want to address right now is this color space layer, or color space warning. What this is telling us is that, hey, you really want to be in the linear color space when developing. So we want to go to edit and project settings and to our player. And we want to change in our other settings tab. We want to change our color space from gamma to linear. Now the toolkit and the various shaders and exportation models will do all the flipping that needs to be done to convert from linear to gamma space when it needs to do that for textures, which is pretty much always for RGB textures. But other than that, when it's linear, it will use the linear space, especially for um, encoding things like your metallic value, which you want that to be in linear. So now that we've flipped that to linear here, we can kind of clear out all of those warnings, and we can flip back over to our scene controller, and we'll flip the inspector to go back to the properties of our scene controller object. One of the next best things that is your buddy is the script component. The script component is what gives you all functionality, even if you don't use any of my component. The very concept of adding a script with properties from the editor that you can use in your script at runtime to manipulate that instance or that entity that you are attached to, or your entire game object if you so chose. Now, our scene controller, we'll make our first script component. We'll attach it to our scene controller here. The scene controller you really want to be like your main driving force of the game here. So we're going to say add component, and we can either add it from here, or we can hit the components here and go to Babylon and click our components, and out of our system components, we want to add, you can add all of the various kind of components that you want to add on there. For the scene controller, actually what by adding the default scene controller on here, you get a built-in component called the Babylon scene component, which kind of gives you built-in functionality that you don't have to make a specific back-end functionality for. So just by having the default scene controller on here, you automatically get a component that's an editor component for all of these options. I want to create an additional component on this scene controller to control my specific game functionality. So I'm going to create a script component, and we're going to add a whole new component to this scene controller component to control our game. So we're going to go to our game, and we're going to go to scripts. We're going to right mouse click in here, and we're going to say create. We're going to go to Babylon. I'm a TypeScript guy, so I'm going to create this in TypeScript. And I'm going to say create a scene controller. And this is going to create basically a mesh-based controller, or a mesh-based component, but it's designated for a scene controller to be that one kind of controlling component that gets called first in the life cycle of our game. So I'm going to just call that scene controller, and I want to copy that name there, scene controller, because I am going to create another component that has the same exact name, that is this time an editor script component. And this is the C# component. And I'm going to paste that scene controller name. If you make them the same name, the toolkit will name the classes of the controllers the same, so that it's already kind of made out for you with all of the relationship between the C# editor component and the backing TypeScript class. So I just double clicked my scene controller component, and it brought us up in our script folder here, and we're on our C# file in Visual Studio Code, and it has set up for us one property called hello, basically just the hello world. Since we called that our component scene controller, it pre-filled out all these classes for us, saying that this is our main class, and this is our backing class called scene controller, and this is our TypeScript based class that has a life cycle. Basically, you have a ready, start, update, after, and destroy. On this component here, we have a public property called hello. Just to get things started out here, we'll utilize that property. So we're going to create a private property in here, and we don't even actually need to create that one private, because we're just going to say hello at the start. So we're going to come down here and create a local variable called hello, and we'll make it a string, and we'll make this variable equal to, we'll use the mesh component base class has a bunch of properties and methods to help game creation and more of Unity style. So we're going to do a get property, so we can get our editor property, and it wants a name, and our name of our property was called hello, and we'll give it a default value, and we can say hello world. So now when we start our component out, we will check for an editor property called hello, which is this property here, and we give it a default value just in case it doesn't find anything. And we're going to say console.log, and we'll say our scene controller says, and we'll say hello. Now we'll take those and we'll save both of those files, because that's our pair. That's our C# is our editor component, and its only job is to just get properties and to specify our backing Babylon class, which is called project scene controller. So this is our project scene controller class, which is a subclass of a mesh component that has a life cycle. Now, when we pop back over here to our editor, we can, if you're not sure that the editor has rebuilt the project, I kind of put this little button down here so you can force rebuild the project. It probably rebuilt when I hit the save button, but I wasn't sure, so I'm just going to force rebuild that there. So that creates our two components, our two files, which is really one component called scene controller. We're going to go to our scene controller. We can either go add component, and we can come down to the script section, and our project was called my project, and we can add our scene controller here, and or any C# guy, you can just select the component and just add drag the C# guy right over there, and that adds that scene controller component to this game object. And then we have our backing class here, and it has an hello world, and ours will say hi Mackie. And now we'll just build that. Takes a couple of seconds. And again, the overhead is about 6 to 8 seconds for the whole script gathering compilation thing. But in the big scheme of thing, that is pretty small compared to the development times of or build cycles of Unity and other Unreal, especially things like Unreal. But now let's go look at our console here, and we have our log says our scene controller says hi Mackie. So there's our first script component that's up and running, and we can kind of use that component to control our game flow, our main game flow. We can get references to other components and game objects and do whatever we want. Let's get this guy some color on here. So let's go and create a couple materials here. We're going to go into our materials folder. I'm going to right click and say create material. Coming from the Unreal world, the naming standard was like an M under. I still like to use that for my material. So I'm going to create an M_ground material, and I'm going to go create another material that I like to call for general usage called my Amiga material. So I'm going to create, I got this from Delta. So we called it Amiga, not Amigo. Now in our Amiga material, we'll keep it standard using a standard shader, but we're going to select our Amiga texture, and we're just going to drag that Amiga texture right onto that cube. So that applies, if we go look at our cube, that applies that texture to our materials. And now we got a little bit of cube so we can kind of really see that guy. And then on the ground, we'll just give that one a color here. So we'll just make it more of a brown, goldeny color, maybe a little lighter. That looks good. So now we'll select that, and then we'll just drag that onto the ground. So now when we hit our game, we kind of got like a blue background with a brown ground in our skyline and our nice cube up there. Now that shadow looks a little bit more rich. I'm going to just go to our directional light. I'm going to add a component. Now you get shadows by default, but you get the default values for them. If you come here and you add a shadow map generator component, you can specify and change these values here. I'm going to crank this up a little bit to 2K. And I'll still use this same algorithm for the filter map. So I'll keep it on blur close exponential shadow. And I'll leave the rest of the settings there. But now we have a little bit of color, and we will just build the scene. So we created some materials there. We created a script component, and we're going to rebuild and see what we come up with. Takes 12 seconds, not bad. Got our splashy. Now we've got our ground, got our shadow. We've got our cube with some coloring. So now you kind of see the difference. Kind of stands out a little bit better. Let's put one more script component on this guy, get him going here. Let's drop down to here. Let's rotate that guy. Everybody's got a kind of a rotator type hello world deal going there. So we're going to go to our scripts folder. We're going to right mouse click, and we're going to create, instead of a scene controller, we're just going to create just a mesh component. And we're going to call this, we'll call it my rotator. And I'm going to just copy that from here. Makes it easier. And then before I do anything else, I'm going to create an editor script component to match it and call that. It's supposed to be my rotator, but I don't think I named it right. And I think I have a duplicate. So let's see. Yep, that one's a duplicate. Let's just delete that one. That is my original one. This one, I must didn't copy that correctly. So now let's try and copy that. And then we'll create a new script component again, and then I'll paste that. There we go. Now we have a matching my rotator backing script TypeScript class and a my rotator editor script component that's being compiled right now. Now that it's compiled, we can double click that, and now we come up in here, and in our rotator, let's just change these properties up. We're going to call this rotator properties, and we're going to make this a float, and we're going to call this rotate. If I can spell, we're going to call this rotate and speed, and we'll make this 1.0f. Now, all properties that get serialized have to be a Babylon property. It's kind of why we make that hello world. They'll just kind of see how those get made there. And all Unity ones can have things like ranges so that you don't go too nutso on the rotation speed. We can say we're going to limit him to 0 to 10. So now you can only go 0 to 10, and it'll make a slider on the editor for it. Now that's our rotate speed property that we set up in our editor. Now I'm going to cut and copy that rotate speed guy here, and I'm going to open up my backing class for it. Now this one we probably want to keep a actual property. So I'm going to create a private property this time, and we'll just paste that there, call it rotate speed. It'll be a number. And we'll give it a default value of 1. Actually, don't need the F in TypeScript. Now, you get various stages of life cycle. Execute when ready is kind of after the component has been constructed, maybe attached to something, but before the actual game render loop. The very first frame of the game render loop will run the start, then all render loops will run the update, and then after comes after that, and then destroys when your component is cleaned up. When I'm grabbing properties, I like to do that in my ready function. So I will go this dot rotate speed, and we'll use our built-in get property function to get our editor property, and we will grab our editor property that we'll call rotate speed, or it was called rotate speed, and we'll give it a default value of 1. Now we'll come down here to our update function, and we will say this dot mesh, because we've made a mesh component. Entities and meshes are the foundation of what you're controlling, and this particular entity is a mesh component, so we can say and reference the abstract mesh. So we'll just reference this dot mesh dot rotation, and we'll set its Y rotation. Actually, we will append to its Y rotation, and we will say this dot rotate speed times this dot the managers, the scene manager, the whole lifeblood of how all of this stuff runs. And it's available in every object by this dot manager, and we will call it delta time. And now we can get rid of those. Those are really there kind of to say, hey, these are what you can do. So we'll just clean this up a bit. We're not going to use any of that. Now we have a nice clean component that just is going to deal with rotating its entity or its owner component by whatever speed that we say. So now we'll save everything. So now we have our rotator backing class. We have our editor script component that where we can place a floating property. And when we pop back over here, now it's going to compile our script. This is the Unity editor compiling our new C# rotator class properties. So we're going to go to our cube, and since we're right here, we can just grab our rotator C# and just drag it over there. And now we have our rotator property attached to our cube. Our first script was attached to our scene controller. It doesn't move. It's kind of just our main guy, and it's kind of where we were saying hello. Now we're going to actually attach a piece of functionality to the cube, and its only job is to rotate. And we'll just leave it at 1 for the moment, and we'll just say build. So it takes about 12 seconds. So twiddle your thumbs for about 12 seconds. It's still a great compile time compared to things like Unreal. But and we're making a completely exported out web game. So now here's our web game, and now we have our components spinning around at with our rotate speed set at 1. And just to show that it's attached there, and the whole reason of doing the script components is if we want to speed that up, we can come select that to 5, and we'll rebuild. And let our TypeScript compile. Still about 12 seconds, and show that. Now it's spinning a lot faster. So now you have the basic makings of pretty much everything that you need to do. Even if you chose not to use any component from me, you can take an empty game object, attach a script to it, put whatever properties that you want to show up here in editor time, and you decide what you want to do with that property for your game. But it's nice to use the full components and the whole structure of having a scene controller and having a master guy run your scene and life cycle. A ready, a start, an update, an after, and destroy. That is the same type of life cycle that you would have with Unity. So you really have complete control over everything, whether you choose to use components or not use components. But script components in themselves are your lifeblood. So there it is. Hopefully that will get you started in Babylon Toolkit development. See ya.